what we just did right there in that warm up was we just solved a proportion using cross multiplication. We're going to continue on using that same idea, except instead of just doing regular proportions, we're going to kind of pair them up with some pictures, right? Because it's geometry as we go through. So we're going to start with just a couple definitions. And then once we do our definitions, we'll go in and we'll do some example problems. So let's just start at the top with a proportion. So like I said, we just did two proportions right up here for our warm up. A proportion is an equation that states that two ratios or two fractions are equal to each other. Two ratios or fractions that are equal to each other. A proportion is written as A over B equals C over D, which is just a general way to write it. But a proportion essentially just means it's two fractions that you set equal to each other, just like our warm-up. The cross product property is the same thing as cross multiplication, or like you guys called it, the butterfly method. It's just multiplying the numerator and denominator that are diagonal, so A times D, and setting it equal to the other multiplication, the other side, C times B. It does not matter which order you decide to do, like first or second, as long as you're multiplying diagonally. That's all that matters. Now, I'm not moving it. I'm leaving it right there. The next section is similar polygons. So we have already talked about polygons or shapes that are congruent, which means they're the same size and the same shape, right? So if you hold your hands up to each other, they are congruent, right? They're the same size, they're the same shape. Yes, well, they should be, unless you've got a deformity, which in which case it doesn't work, but otherwise it should work, right? Your hands touching each other, these are congruent to one another. Now, if I hold my hand up to Jess, okay, obviously we have the same shape, but different sizes, right? We have similar hands to each other. Ours are not things.
His hand's small.
His hand is smaller because he's younger and you guys are still growing. And I am not. I'm an old woman now. So your hands to each other are congruent, but your hands to someone else's, right, are similar. So a polygon that has the same shape but a different size is a similar polygon. Same shape, different size. Okay, polygons are similar if it has two different properties. Property number one, corresponding angles are congruent. So that means angles that are in matching positions have to be the same. Okay. Polygons are similar if corresponding angles are congruent, and polygons are also similar if corresponding sides are proportional. Corresponding sides are proportional. What that means is if you make it a fraction, like the side lengths, if you make them into a fraction, all of the side lengths should have the exact same fraction. That's what proportional means. Should have the same decimal or same fraction or ratio, however you want to call it. The ratio of corresponding sides, so this piece that is proportional, this is called the scale factor. So whatever that fraction is, if that fraction is the same for all of them, that is called the scale factor. And then if polygons are similar, their perimeters are also proportional. What's a perimeter? Perimeter, what's a perimeter?
Outside.
The outside, yeah, distance around the outside of a figure. Okay, So polygons with the same shape but different sizes are similar. They need to have all of their angles match, and they need to have the side lengths have the same fraction or same ratio in order to be similar. So we're going to do an example, and we will check out some similar triangles. Can I move it up? Does anybody need it still? Okay. All right. If you look at these two triangles here, you will notice they are similar, meaning they have the same angle measures, which are marked, but obviously one of them is larger than the other, right? One's been dilated or made larger than the other one has been. So we're going to check and see if these are similar triangles by looking at their scale factors. Okay, so the scale factor again just means you are dividing or making a ratio out of the side lengths, making a fraction. So what I'm going to do for my fraction, you can do it either way. I'm going to do the small triangle divided by the big triangle. Small triangle divided by the big. You could also go big divided by small. It doesn't really matter as long as you keep the pattern the same for them all. So here's what I'm going to do. I'm going to pick one of the side lengths of the small triangle. Okay, so let's start with 8. Which side length does 8 match up with in the bigger triangle? 8 matches with 12. Those are the two smallest numbers in the triangle. So 8 matches with 12. I need to check and see if that proportion is the same for all of the side lengths. So I need to see if it's the same as another side. So if I pick another side of the small triangle, like 10, which side matches with 10? 15. And I also need to check if that's the same as the last side, which is what? 18 over 27. Okay, so I want you to take your calculators. I want you to divide those numbers and see what you get as a decimal for those three. Let's see if they're the same or if they're different. All right, what did you notice? They all equal the same thing. All of them are 0.6 repeating. Huh? I did do all three of them. I put 0.6 repeating. The little line on top means it's repeating. It goes on forever. So you don't have to write it out a bunch of times. Okay, so because all three of the sides have the same scale factor and all three angles are the same, these are considered similar triangles. Their sides are proportional and their angles are matching or congruent. So last thing we can do is we can write a similarity statement or a sentence. Okay, so here's our sentence. Triangle. I'm going to call this one CAB. Triangle CAB is similar to, and the similar symbol is just the squiggly line, nothing else. This means similar. Triangle CAB is similar to triangle, and I have to name it in the same order. What would the second triangle be in the same order? FDE. So order does matter here. So similar triangles have congruent angles and proportional side lengths. All right, when you're done with that, flip it over. We're going to do some examples. All right, I'm not going to do all of them with you. I'm only going to do 2 with you. Bless you. And then you're gonna be on your own for the rest. So for the problems on the back, it says, given that the polygons are similar, so I'm telling you they are similar, use a proportion to find the value of each variable. So you need to make a proportion to solve for X. So we're going to start with example number 2. Example number 2. There are 2 triangles in this picture. Triangle MNP is this one on the left. This is the small triangle. I want you to label it as small. And then, I'm sorry. Sure. And then triangle QRP is the one on the right. It is the big triangle. Jason. Draw number 2. Okay. So what we're going to do is we're going to set up a proportion. We are either going to do small divided by big or big divided by small. It does not matter what we choose as long as we choose the same thing for both proportions. So what is one side length that you see? 28. Okay. Is that part of the big triangle or the small triangle? That's the big one. So we're going to do big over small. Okay, 28's the big. Now, which side matches 28 in the small triangle? Are you sure?
Yes,
How do you know?
I have eyes.
Hmm,
Because
That's-
lunch is flipped over.
yes, it's flipped over. How else do you know that it's definitely the 24 and not the X plus 8? You can't go by just what it looks like.
Vertical angle theorem.
What do you think, Violet?
Because like with the triangles that lists in the side, these wouldn't you correspond to P&M.
Perfect. So Violet's saying if you look at the sentence here, QP, first and last, that matches with MP over here. So if you go by the sentence, you'll never mess up. Okay, so 28 over 24, that's our first proportion, big over small. Now, when you write your next proportion, it has to still be big over small. You got to keep the same order. So what should go on the top? What expression should go on the top? Yeah, 3x minus 9, the big triangle, over what? What should go underneath it?
X plus 8.
X plus 8. And now you have your proportion. And once you have your proportion, what can you do?
Cross multiply.
Cross multiply just like the warm up. That's not option. Okay, take a minute. I want you to try to solve that on your own. I set it up for you. Now you got to do the algebra.
It's
Your answer should be a whole number,
That nice.
no decimal.
Smart. Go by myself. No, I don't.
And once you're done, you can hop on to another problem because you are gonna have to do the entire back.
That's good.
Perfect.
Very, very good.
So move all your X's to one side. Number in front, just review it. So you gotta multiply 24 times the 3x, again 24 times -9. What's that mean?
Wait, it should be a whole number.
Should be a whole number. Shoot.
I don't know, I said what I meant.
No, because we're being recorded right now, so maybe don't. We don't do that, since I'm sure.
I hope. Hold on.
Noise. Where?
Did you? I don't think
Real quick.
I don't think this is 96. It's 24 times. Ah,
Do you need help with your pump?
oh, it's a 9.
The 9?
That's a 9.
Oh my god.
Oh my gosh, that's why. That's the only reason.
I suppose you have.
Your setup was fine though. Beautiful, good job.
You're so stupid.
Now you lose two.
So if you look at
You're
the
so stupid.
21 is, I'm gonna come over here because when EF matches with
Oh, fine, then go get it.
we see there's your number.
What are you doing this in three?
When there's 3 what?
Excellent line.
Just go do it. I need to head that.
For question 1, that 45 over y.
45 JL over NL, yeah.
This is 3, what do I do there?
Well, don't do the one with the X then for the next one, because you don't want to have a Y and an X together, because how are you gonna solve that?
Alright, so there's only you 2.
Right.
It's gonna be cool.
Still 7 equal, yeah. Okay, does yours look like mine for number 2?
Looking at what 10 is doing.
Yeah.
X equals 10?
Yes.
Where did I lose anyone anywhere?
Oh, that's,
Yeah.
Yeah, Violet.
I don't know what I did.
Okay, let's check it.
Someone is lost.
Sorry, no. I'm not.
Because you have to distribute before you can start subtracting. So you have to multiply 20 times X and 20 times Z before you can start. Since that's my. Trying to go out of order of operation. That's why. Okay. What other questions can I answer about that first problem? So it's a lot of, there's 2 like big parts to it, right? Part 1 is just, can you write the fraction correctly? And whatever order you pick, if you do big over small, then you gotta do big over small for both proportions. If you do small over big, that's fine, but you gotta do that for both proportions. Whatever pattern you pick, you gotta keep it going. So first is just being able to write the proportion. Second is just being able to do the algebra. And when you do the algebra, make sure you distribute first. You're gonna have to distribute for just about every problem. So make sure you distribute first. Okay, I'm gonna set up number 3 with you, and then you're on your own for the rest. No, because once I set up number 3, you'll know how to set up number 7.
Oh.
Okay. Number 3. So this problem, I know it looks funky, but in number 3, you've got 2 triangles that are laying on top of each other. They're overlapping triangles. So you've got triangle ABC. That's the big triangle. Easiest 1, 2, 3. Okay, triangle ADE is laying on top of it. That's this small triangle here. What?
Guys.
Okay, now, when we go to write the proportion, it does not matter if we do small over big or big over small, as long as we keep it the same. So somebody give me one of the numbers there that you see for one of the sidelines. 15, okay, is that the small one or the big one? Okay, so we're gonna do small over big. All right, which one matches with 15?
What? Oh, 3.
2x plus 3, good. So I did 15 was my small one, which means small goes up here. 2x plus 3 is my big one. 2x plus 3 goes in here. Okay. So 15 over 2x plus 3. What number do I have to pick next to go on top? I have to pick 20. Yeah, because that's my small one, 20. Over, what's the big one? It's not 8.
Also 8 and 4.
Why is the 8 there?
It's.
8 is just saying this small piece.
It's in.
28, because I want to know the whole side length. Right, the whole blue triangle there is 28. Yeah, so don't just go for 8, because just think about it logically for a second. If you're doing small over big, high, 20 over 8, that doesn't make any sense, does it? Right, it would have to be a smaller number over a bigger number. And then you, from here, cross multiply. So 15 times 28 equals 20 times 2x plus 3. And then it's algebra. Okay. So you've got the remainder of the period. Oh, you've got a lot of time. You got about 15 minutes.
No, it's not, it means that we're doing this by small.
You got about 15 minutes. You are going to finish up. When you're done, I'll check it. If you don't finish today in class, it's homework and you are going to get a grade for it tomorrow. Yeah. Okay. If it's easy, then why don't you do it for an easy 30 points? Oh, you would do it. I'm sorry. I apologize. Let me reel that back in. I'm sorry. I'm sorry. You can take that one, Xavier. Stop recording.
Whoa, thank you.